one of those tricky concepts that it's easy to kind of brush off and pretend like it doesn't exist or try to just hope that it works out. But it's embedded in everything you do in JavaScript, and so there's really no way around it. And the sooner you kind of bite the bullet and try to really understand it, the better. Um, what pass by what pass by reference versus pass by value really means, kind of in a more layman's term, is when I copy information, like how does that actually work? Right? If I was to say, let x equal 6, and I say let y equals x. If I change x, does that change y? Right? Similarly, if I say, let x equal an array, right, which is, 1, 2, 3, and let y equals x. If I change the original array x, does it change y? Right? And so one of the things we know is in JavaScript it's a lot different for us to say, hey, I have two variables, if you will, that are pointing to the same exact thing, versus I have two things that are just copies of one another, right? So if we go back to the Xerox example I was using a few days ago, right? It's basically the same as saying like, oh, I have a copy of a book. Well, are we both looking at the same copy of the same book? When you pair program, are you looking at the same computer screen? Because if you are, that means whenever someone changes one version of it, it changes it for everyone else who's also using that version, right? The analogy otherwise would be, let's say I hand out 30 copies of a test to everyone, right? Everyone has their own copy. If someone changes their copy, it doesn't affect anyone else as well. And so basically in programming, when do we see situations in which things are copied, and versus when do we see situations in which things are actually referring to the same exact thing? So in day or over the weekend, Sam probably talked a little bit about primitive data types versus non-primitive data types, or also known as complex data types. The primitives in JavaScript that we talked about are pretty straightforward. Um, Strings, numbers, and booleans are probably the big ones that we've been consistently using. Nulls, undefineds are obviously, there's not much to say about them at this point. They're just kind of there. They only have one value. And then symbols we definitely don't talk about in this class, right? But for strings, numbers, and booleans, we call them primitives. Do you did Sam talk about why we call them primitives, or rather what makes them different than what we call the complex values, which are objects and functions?
He said something about how they're stored. I don't remember, but
Okay, how they're stored. Great. That is true. Yes. Yeah.
Like what you can do to them.
What can you do to them?
So like strings, I think can only have certain methods or functions done to them, whereas you have more options with objects and functions.
Not necessarily. Strings are also classes in JavaScript, so you can add as many things as you want to, as many functions as you want to a string or a number class. And numbers are also classes in JavaScript. In fact, so are booleans. Okay, so they're all classes. But the point is that like you can actually change them as much as you want, and so it's not you can do more with one data type than the other. Yeah.
Because they don't have the prototype inheritance.
They do.
Okay.
Yeah, they do. Like I said, like they're all instances like every number you ever see is an instance of the number class, and so they all inherit from the number class. It's the reason why I can just do a string dot length. That length property is inherited from the string class, so they definitely do inherit. The quick and dirty answer for why we call these primitives and why we call these complex is because primitives are not changeable, whereas complex values are changeable. So what do I mean when I say not changeable? In JavaScript, a 6 is a 6, right? A 5 is a 5. A true is a true. A string is a string. And, and a string with 5 characters is always going to be that string with 5 characters, right? If you remember, if you kind of go back to over the weekend, you all did a workshop where you had to capitalize every other letter in a string, right? And the way that a lot of you probably first approach that problem is say, great, let me just go through every single letter in the string, capitalize every other one, and you probably found that that didn't work. Instead, what you do is you had to recreate a brand new string, right? You create a brand new string in which you start with one letter, then you add the next capital, then you add the next lowercase, and the next capital, etc., until you finish up, right? And so what that does is that demonstrates kind of this unchangeable, or in programming what they call the immutability property of primitive types, which basically means once you create a string, a number, or a boolean, you can't ever change that value. Now, if I say let x equal 5, right, and beneath I say x equals 6, I'm not changing 5, right? I'm changing the variable x. And so that's the distinction there is we're never changing 5. We're never changing a number. We're never changing a boolean. We're also never changing a string. What we're really doing is we're using that variable and saying, hey, why don't you assume another value, right? So like so for example, if I was at a library, right, and I was checking out a book, and I say, oh, I don't want this book anymore, I want this other book. Well, basically what it means is this new book is now tied to my account, but the old book is still there, right? If you think of my account as a variable, like when I first check out the original book, my account is associated with this one book, right? If I want to check out a different book, my account is associated with a new book, right? It doesn't mean that I changed the original book into my new book. It just basically just means, hey, I'm now associated with this new book, right? And so just kind of hammer this point home here. We can't change strings, numbers, and booleans. For objects and functions, mostly we're talking about objects in this class. We are able to change it, right? If I create an array with 1, 2, 3, if I do array.push 4, guess what? It changes the array, right? If I have an object with 5 key value pairs, and I say object, I put key 6 equals true, guess what? I just added a brand new key value pair to my object, right? And so with objects and arrays and functions as well, we're able to create it, but then change it and customize it later on if we feel like it. We don't have the luxury with numbers, strings, and booleans. And so that gives way to some pretty interesting behavior. So if I have something like, if I have an example like this, right? British city equals York, American city equals British city, and I overwrite American city with mu plus American city. When I console log out British city, I get York still. When I console log out American city, I get back New York. Okay? And I think everyone is probably pretty clear on where we get New York. I think the point here is, well, if British city equals York and American city equals British city, then how come British city didn't change alongside American city, right? Because American city clearly changed; it became New York. Why did British city not change? And the lesson here for this lesson really is that for primitive data types, for numbers, booleans, and strings, because those values are not changeable, whenever we make a reference or whenever we copy that value, so in this case, whenever we say let American city equal British city, we're not linking this value directly to this instance of a string. Instead, what we do is we actually copy the string and copy the value and give American city an identical copy of the string, in this case, York. And so what that also means is because we've now copied the value of York into American city, whatever we do to American city doesn't affect British city, right? Like if you give me a piece of paper and I Xerox a copy of it, I can write all over my piece of paper. It doesn't impact your, right? Like your paper is going to be the original one. It's going to stay in whatever state you want to maintain it. So here, where British city is equal to York, when I say let American city equal British city, what JavaScript is going to do is it's like, okay, great. What is British city? Oh, it's a string, right? A string is a primitive, and so therefore, when line 3, when I say, hey, let this variable equal the string, what I'm really saying is let this variable equal a copy of the string, right? And so British city and American city have no more connections. I can change one without changing the other. However, that would not hold true if we were dealing with a complex data type like arrays, right? So on line 2, we have this British city, and we set equal to an array with a string York, right? It's an array was one thing. British city is not the string, by the way. British city is the array, right? So let's just make sure we kind of had that distinction in mind here. And so now when we say let American city equal British city, what JavaScript now does and says is okay, great, what's British city? Oh, it's an array. Well, an array is something that can be changed later on, right? And so if this person wants to kind of have a British city and American city both be pointing to the same array, it actually has to be the same exact array, because it's very possible that they could change this array down the road, and both of those variables are pointing towards it. It needs to know that this change has happened, right? British city is equal to this array. American city also needs to point to this array. And because if we don't, if we make a copy of this array and put it here, then it means wherever we change British city, is that it won't change American city, right? And with primitives, we have the luxury because with primitives, we know that, well, guess what? This value can't change. With complex objects, we don't, right? Complex objects, like, hey, someone could change this, in the next line, and we need to make sure that everyone who's currently looking at this object knows what the latest version of this object is. And so on line 2, when we say let British city equals this array with a string of York, and then beneath it we say let American city equal British city, it basically means we have two variables, American city and British city, and they're both pointing to this exact instance of the array. And so therefore, when I change the array of American city.unshift new, which basically adds new to the beginning of the array, guess what? It changes it for American city, obviously, but it also changes it for British city because once again, both of them are now pointing to the same exact thing, right? So it's like almost like like if you and your partner were pair programming on one computer, if one of you types a letter, right, the other person sees it on the screen, right? Similarly, when you type a letter on your screen, the other person sees it too. Why? Because you're both looking at the same exact screen. There's only kind of one value there, right? And you both have access to it. Okay, so that's basically the main difference between how complex versus primitive data types work with regards to we call it passing values back and forth, but what it really means is kind of establishing a relationship between a variable and a value, right? So on line 2 here, we're saying this variable British city points to this value. On line 3, we're saying this variable American city points to this value, and so at every single junction here, what we're basically doing is we're associating a variable with a value, right? And what this lesson is trying to tell you is that, hey, when the value you're trying to associate is primitive, we make a copy of it. When the value we're trying to associate is a complex, then we actually give you that exact object. Any questions so far? Cool.
This is a silly question, but I noticed that you used unshift, and I always have to look these things up on MDN whenever.
I think it's totally fine. Emissions, I think what emissions does is I think they have the ability to look at your screen too. So if you tell them like, hey, I'm going to Google an MDN for what the arguments are for a function, they will never hold that against you. If anything, they'll probably be impressed that you know how to look at documentation. Yeah, it's not a game of memorization.
Okay, sounds good.
Yep. Okay, cool. So, basically that was the entire lecture, and now we're just gonna go through a few slides and kind of use more arrows to illustrate what I was just talking about verbally. So let's talk about assignments with primitive values, right? So here on line 4 we have a variable called first, and we're setting it equal to the value of 20. And the idea is we have a variable called first, and the value here is 20. And so whenever I call first, it's equivalent to me saying, hey, what's first, or what's the value of first? The value of first is 20, so therefore I'm looking at 20. Okay. Then on the next line, if I say first equals 30, what I'm really saying is this variable first isn't changing, right? We're just having this arrow now point to a new value, right? In this case, 30. And then when we do let second equals 30, notice how we have a variable called second and we have a value called 30. And even though these two values have the same value, like they're distinct, right? If I do first plus, or sorry, in this case, if I do second plus plus, it now repoints the second value to, it doesn't change the 30 to a 31. What it really does is it's actually pointing the variable second to a new value called 31, or a new value 31, right? Because once again, we can't change numbers, right? All we can really do is repoint this variable to the new number, or the new value that we want. And obviously, even though these two both used to be 30, it's like, me and you having the same exact car. If you add rims to your car, it doesn't change my car. Like, so even though these two values are both 30, like if one person decides to change their value or point it to another value, it doesn't impact the other person, right? The other person is still 30 because those two are very distinct things. Cool. Okay. So to extend on this example then, we have first equals 20, we have second equals first, right? So here we have a variable called second, and we point to the value first. And once again, just kind of keep in mind, right? even though it might say, well, second points to first and first points to 20, therefore second must point to 20, realize that, once again, this is like the tricky part of primitives, right? Is this idea that like, well, we can never, basically, the rule of thumb with primitives is that if you draw it out with arrows and values, no, you can never have more than one variable pointing to a single primitive at any given moment, right? Which means you could easily have, two values of 20, right? 20 and then 20, and have a variable point to each. But because 20 is a primitive, you will never have more than one variable ever pointing to it. If another variable tries to point to it, JavaScript says, oh, great, let me just make a copy for you so you have your own version of 20 to play around with or do whatever you want to do, right? So once again, on line 2 here, when we say second goes first, then first goes 20, well, JavaScript says, okay, oh, great, you want to mimic whatever, you want to copy, you want to point to whatever first is. Well, first has a number, so here, let me make a copy of a 20 for you, and here, you have your own copy of 20, right? So the variable second has their own variable of 20 to play around with. Probably should put a let in front of that second there, but you get the idea. And so once again, when we increment second by 1, it has no impact on first because guess what? This entire time, second has their own value of 20 that can do things and point and like pass around. Yes?
But if you change the value at first, it would have an impact on second.
It would not, because notice how the first points to this value of 20 and the second points to this value of 20. If I change anything here, there's nothing that connects these two variables anymore.
So it wouldn't like recopy the information. It would be like whenever you set second equal to first, whatever first was equal to at that time is the copy you get. So even if you go back and change first, it won't send a new copy.
Yeah, exactly. So I go back to like the human Xerox example, right? If you have a piece of paper and you Xerox and give me a copy, if you start writing on paper, mine doesn't change, right? Mine is still whatever you gave me originally.
Right.
And similarly, if I start writing on mine, it doesn't change yours, right? So basically, after you copy it, like literally, if you Xerox two pieces of paper, like there's no connection between them anymore, right? They exist as individual entities. And so that's the point of this arrow, of these arrows here, is that like, hey, look, we have a value 20, we have a value 20 or 21, whatever. Yeah, there's one variable pointing to it, and there's really nothing linking this first row to the second row. They are strictly independent of one another. Okay. However, with complex variables, it's a little bit different, right? With complex variables, we introduce this idea of a reference. You can also think of it as an address. Basically, like almost like a place in your computer's memory where this value exists. So if I have on line 7 there, if I have a variable called first, and I set it equal to this value of an array of 10, 20, what it really is saying is, hey, I have a variable called first, I have a value called 10, 20, and basically what I'm going to say is this value is being stored temporarily at this address, and so this variable points to this address or this reference, and this reference stores this value. Okay? If I then change the first array, right, but saying first push 30, right, what the JavaScript will do is say, okay, great, variable, what's variable first pointing to? It's pointing to this reference. Okay, great, and what's the value at this reference? The value at this reference is 10, 20, an array. Let's push 30 into it. So now this value becomes 10, 20, 30, and if we just look at this still, the variable first is now equal to 10, 20, 30. Okay? If we try to get a little bit more creative here, sorry, too fast, too creative. Oh, wow, I can't change it, can I? I can't stop it, can I? Oh, I can, good, okay. Here, on line 1 versus line 3, notice how we're creating two variables, one's called first, one's called second, right? And we're setting equal to the same value, but are these two things connected in any way? They're not, right? They have the same value, yes, but each of the value lives in a different reference, right? Each of these values live in a different address, if you will, right? It's like saying two houses with the same like coffee table, right? Like, yes, they're the same coffee table type, but they exist in two different places, and they have no connection to one another. That's why this variable first points to one address, which points to this value. Second points to another completely different address, which happens to also store the same value at this point in time. Why do I say that at this point in time? Because now if I change second, I do second, I push 30. Well, in one of the houses, if I chop off one of the coffee table's legs, does it change the first house at all, or the first coffee table? Not at all, right? Like these two are distinct things, and so that's why first is pointing to its own reference, which has its own value, and that's completely untouched by whatever it is that we're doing to the second variable, which points to the second reference, which points to the second value. So in this case, second changes, but first does not. Okay, great. And then lastly, the last example that we're going to talk about this in is when we start to have multiple arrows pointing to the same thing, and this is where things probably get a little bit more confusing, right? So we start off with our first variable, still a reference, still a value. Oh, sorry, a little too fast. Still a value of 10, 20. Then I say let second equal to first. Before, if this was just like a pure number, right, we would just copy the number and give second its own copy of the number. But because we're now dealing with an array, which is a complex data type, we can't give it a copy. What does it say? Oh, great, here's my actual thing, right? Like you now have access to my original array. And the way we do that is we create this variable called second. What does it point to? Well, rather than pointing to this value directly, what it does is we actually point to the same reference. Like this part is a bit trickier to explain like verbally, but just know that basically this variable called first and this variable called second, they're both looking at the same exact address, right? And because they're looking at the same exact address, by definition, then they must also be looking at the same exact value, right? Think of the U.S. address system, right? Like every single house can only have one address, right? If I give you an address, that by definition has to only lead to one place in the U.S., right? Same idea here. If these two variables are pointing to the same address, then that address has to take them to the same exact value. So when we copy so when we create the second variable, what we're really doing is we're saying, all right, great. I'm not creating a copy of the value of first. What I'm creating is a copy of the reference of first, right? Like what's first's address? And first's address in this case is 0x001. So therefore, second also points to 0x001, and because they're looking at the same address, by definition, they will eventually point to the same value. And hence the name of this lecture, which is pass by value versus pass by reference, right? With primitives, we pass by value. We're copying the value and giving you an actual copy of the value. For complex, we pass by reference, which means we don't give you a copy of the actual value. We actually give you a reference to the original value. We give you a reference to where this thing is stored so that you can actually change this, which would then change it for everyone else. So now if I do second.push30, Java says, okay, great. Second, what are you pointing to? I'm pointing to this reference. Great, what's the value of the reference? 10, 20. Great, let's add 30 to it. And now when I print out first and second, trail backwards. Well, yeah, there's this value. If we change this value, everyone who's looking at this value is also going to see the changes that we just made, right? And so therefore, when we console log out first and console log out second, we actually get the same exact thing. And these two will always have to be equal at this point in time because by definition, they're pointing to the same exact reference, they're pointing to the same address, so their values have to be equal. The only way to break this chain out, which we'll see in a later slide, is if we reassign this variable to something else. But as long as these two variables are assigned to the same reference, they have to be equal. Do you have a question?
Yeah, if you wanted to avoid changing the first array, could you say let second equals an array with the same things, but not saying equals first? Like if you have an array that is 10 and 20, but it doesn't.
Yeah.
I think it was.
You mean this side here?
Yeah, like that. Okay, so we did see that.
Yep.
Okay, yeah. That. Yeah.
Cool. Okay, great. So now, so in arrays 1, so the last lecture on Sunday, Sam talked about slice, right? And we talked about how slice is like a really cool way to create a copy of an array, and maybe even create a copy of a portion of the array, right? Harry also mentioned that by default, if we don't pass any values into the slice function and we just call it like this, as in with empty parentheses, then what this means by default is saying, hey, can you give me a copy of the entire array? Well, why would we ever need a copy of the entire array? Basically, hopefully now this example is pretty clear. Well, one of the kind of premier situations in which I would want a copy of this array is because, hey, what if I want to do a bunch of stuff to second that I don't want to carry over to first, right? Like I want to have my own sandbox array. I want to have my own array that has the same values as first, but I don't want whatever I'm doing, what I'm testing, to affect first because maybe someone else is using it. And I don't want to impact them, right? And so what slice does is slice creates a new array that's a copy of the array that we're slicing. So in this case, when we do first, point to this reference with this value. When I do second equals first dot slice, what first dot slice will do is basically create another value with the same exact array value, but we put that under a different address. In this case, it's 0x002, and we point second to this new reference, right? And so even though these two values are the same, notice how they're at different addresses, and they're pointing to by different variables. So now we kind of see the same instance we saw earlier, whereas I could do whatever I want to first, or do whatever I want to second, and it won't impact the other one. Yeah.
That's a shortcut of the instance that I was mentioning, basically.
Uh,
Rather than having to rewrite the
yeah.
whole thing exactly the same, you could do first dot slice.
Yes.
Avoid the human error of possibly retyping it.
In like 95% of cases, yes. We'll talk about one reason why this might not work in two more slides. Yeah. But in general, for our class, you can think of it that way. But yeah, there's a few edge cases for why this wouldn't hold true. But yeah, so essentially, this is why we use one use slice. Therefore, if I do second dot push 30, well, great. I'm changing my own copy of the array, so it doesn't impact the other guy or the other person or wherever they've been moving with it. So yeah, so first remains 1020, and second becomes 1020 30. Cool. Any questions? Makes somewhat sense. Right, and this is something that's, every time we're using a string, a number, a boolean, a array, anytime we use any data types in JavaScript, these rules apply. Like up until now, the workshops have been designed in a way to kind of almost shield you away from having to kind of deal with these nuances. But going forward, these rules are always there, right? You can't copy an array differently than what I'm saying here. You can't copy a number differently than what I'm saying here. And so because of that, it's really critical that this is not something that you just kind of gloss over and later on hope that it just kind of works out. You really need to understand this because this is a very fundamental part that underlies every line of JavaScript you'll ever write. Okay. So one thing we talked about with kind of passing values back and forth is using the assignment operator, like let x equals y, or let x equals 20, let y equals x, right? That is one instance in which we're passing the value x onto y, right? We're moving these values back and forth. Another way in which we describe using values and passing them is actually in functions, right? If I have a function that I expect an argument, what we usually say is, hey, let's pass a value into it. Let's pass a value to it. In this case, I have a function. I have a variable called my num, which is 10. I have a function called adds20 that takes a num. It adds 20 to the number and returns num, right? And so here on line 8, when I call adds20, well, first of all, let's just be super this. This is the return value, okay? Return value basically means I give a value back from a function. I give back a value, okay? This is not a console log, and if there's one thing to take away from this class is do not confuse a console log with a return statement because computers don't recognize console logs, right? Console logs are kind of almost purely for human consumption. Don't use a console log and think it means a return because it definitely will not, right? Return actually throws the value back. Console log just prints it to the screen and does nothing from a function's perspective, okay? So what this function does is nothing gets printed out, but it takes in this num, adds 20 to it, and returns a num. It gives a number back to you, okay? And it's only because this adds 20 returns this number that when you let return num equals adds 20 passing my num, this is going to return a number, and that number is going to be stored in return num, right? If this had no return statement, the return num will always be undefined.
It would always be what?
What?
It would always be what?
Undefined, because this function is going to return undefined if we don't have a return statement. And so this function will always return undefined, and therefore this will always evaluate to undefined. Right. So adds 20. Notice how here as 20, we're passing in my num, right? My num equals 10. And so my num, when passing this function, within the context of this function, we're basically looking at something called num here, right? So what's num now? Is num this pointing to the same thing as my num, or is it pointing to a copy of my num? Copy. How many of us think copy? 1, 2, 3, 4. I'm just saying the same. Not anymore. And then 4, you didn't vote. Right. So num has to be a copy of my num. Why? Exactly. My num is a number. It's a primitive, right? I can't have multiple things pointing to the same primitive. I can only have multiple variables pointing to the same complex. If it's a primitive, I can have multiple copies of the same primitive, but once again, each of those primitives can only have one variable pointing to it. And so because of that, on line 4 there, num is equal to 10, but it's not the same as my num. It's a copy that has the value 10. And so on line 4, we do 10 plus equals 20, 10 plus 20, we get 30, and then on line 5, we return 30, right? Notice how this becomes 30, right? And we store it as return num. But notice how these two things are also what? When we pass my num into this function, it becomes num, right? And we copy the value of 10. Here on the return statement, we're basically exporting this variable called num. But what are we exporting? We're exporting a number. So therefore, we're not exporting therefore we're exporting a copy of that number too, right? And so this kind of shows you like kind of the level of detail that you want to think about when you look at these problems. It's just like every time a number kind of moves anywhere, whether it be going into a function, coming out of a function, being used as an assignment, like it is moving. And so we just need to kind of be sure on our side, are we getting a copy of it, or are we getting a copy of the address? Sorry, a copy of the value or a copy of the address. And so here on line 8 now, when I console log out my num, I console log out return num, the point here is to show you that my num, even though I theoretically added 20 to it, like it looks like I've added 20 to it on line 4 and 5, I wasn't adding 20 to my num. I was adding 20 to a copy of my num, right? Another value of 10. So my num never changed, but the return num does change because return num is coming back as 30. Okay. On the other hand, if I have something like this now, right, this is almost identical to the code that we just had, except now instead of my num, it's my array, right? And so I have this function called push this 20. It takes in something, it takes in an array, and we pass in my array. My array becomes array here between lines 3 and 4. And so at this point, is array a copy of the value of my array, or is it a copy of my array directly? There's ever things it's a direct copy, or sorry, is it a copy of the value or is it a copy of the reference?
It's a reference.
Right. It has to be a reference because my array it's a complex data type. We can't copy the value of a complex unless we explicitly make a copy of it first, right? So therefore, by passing in, we're actually passing in this exact array. And so when we do array.push20 and then we return the array, guess what? My array is changed, right? The return array obviously is changed because we see it in the body of the function. But this is to show you that because we're passing in not a copy of the array, we're actually passing in the actual array itself. When we add 20 to that array, we're actually adding the 20 to the original array too, right? So my array and return array are now pointing to the same exact reference, which is pointing to the same exact value of 10 count. Okay. So one of the things we talked about in one of the very early things is the uses of double equals versus triple equal signs. And we say, in general, in programming or in JavaScript, as a rule of thumb, always use triple equal. And so this is more of like FYI rather than actually something that we'll be practicing a lot of. But when we do triple equals, when we use it for primitives, it's pretty straightforward, right? Like two strings of the same characters are triple equal becomes true, right? When we compare complex objects, using triple equals, it's a little bit more nuanced because for complex objects, it's not comparing it based on the value. It's comparing it based on the reference. And so what that means is, in this case, on line 3, I've let array 1 equals 1, 2, 3, array 2 equals 1, 2, 3. If I console log out, does array 1 equal array 2? I get back false, right? Because these two values are identical, but these two values live at different references, right? The way they're created means this is stored under one address, this is stored under another address. When JavaScript's triple equal looks at these and they're like, oh great, it's two complex things. It doesn't care what their values are. It cares about what their addresses are. Because if their addresses are equal, then by definition their value is also equal, right? And so that's why this looks to humans, it looks like it's true, but in reality the statement comes back as false. However, if we do something like this now, array 1 equals 1, 2, 3, array 2 equals array 1, and now we compare it, we get back true because array 1 and array 2 are pointing to the same exact reference, and therefore JavaScript says, oh, okay, great. By definition, you have to be equal, right? There's no way you can have two variables pointing to the same address coming out with different values. Yeah, so when you use triple equals for complexes, just think about this. In today's lesson, we'll also talk about. You'll do a workshop on like what's another way to compare something to another way to compare complex data types. But this is why the triple equal does not hold true the way that we think it does when we compare objects. Yes.
So I have a different question. Is there any method or operator that you can like see if both arrays are the same?
Yeah. So you'll write that in the workshop tonight.
So you have to okay. I thought there's like a special method that you put in between just to check if both arrays are.
Yeah, I mean, like you're right. There probably is somewhere floating out there, but I think for the most part, it's comparing equality for complex data types is something that's like, it may sound like a very standard thing, but it's actually like when in the real world we use it, it's actually quite custom, depending on competition. So one of the reasons why it's a little bit more complex than just comparing two things like that is because of this guy here on line 3. Nested arrays. We've seen them before, right? But one of the things that's really troublesome here is notice how how should I explain this? So we have array 1, which is in the nested array, and then we do array 1.slice. You do array 2, right? Theoretically now we have array 1 and array 2, which both have a different copy of the same value. And in fact, when we console log out array 2, we see it looks the same, and obviously they're not equal because they're copies, right? They don't have the same reference, and that's cool. But the troublesome thing here is actually more in this example. So we go back to array 1 now. We have 1 and then the second element is array 2, 3. Array 2 is array 1.slice, sure. And then if I go into array 1 and I go to the second element here, the next one, I go to the second element and I push 4 to it, this now becomes 2, 3, 4, right? But when I console log out, so array 1's second element becomes 2, 3, 4. Array 2's second element should still be 2, 3, right? Because we made a copy of it. But in reality, what happens when we actually console log it out is we see that it actually also changes. And so the reason why that happens is because slice makes what we call a shallow copy. And what a shallow copy means is if I'm copying an array, what a shallow copy will do is it will go through every single element in the array. If the element is a primitive, it will just make a copy of the value. But if the element is a complex object, it will actually pass that reference into the new array 2. And so therefore, when we do array 1.slice for array 2, notice how on line 13 there, right? The second element is not a primitive, it's not a 1, right? We can't just we can copy the value 1 really easily, but it doesn't copy over the value of this, or it can't copy the value over this array. So it actually passes the reference for this array. And so in array 1 and array 2, the second element, they're actually still pointing to the same exact reference. And that's why that becomes true. And so I guess to respond to both of your points earlier about kind of like, why can't I just have like a really convenient built-in function that just copies and checks it for me? It's because of this. It's because most of the times we don't know how complex the inner elements get. And so because of that, copying something just kind of arbitrarily is actually a lot harder than you think it is. And so in most cases, when people want to do that, they would have a very better they would need a better understanding of the actual data they're playing around with, and they would kind of build more like a homegrown solution for copying it. TLDR, there's no simple way to just kind of blanket copy everything kind of all in one go. It's also the reason why earlier I think someone said like, oh great, if I use a slice, I can just copy everything over directly. In most cases, yes, but obviously if you have complex elements, slice doesn't work anymore. So there are some like restrictions to this. Sorry, I didn't mean to cut you off.
No, I can't believe you're telling us this now because we had to make these things shallow and we used nested for loops. It was crazy. We didn't build in that workshop, right? I can't believe we could have just sliced.
Yeah. Yeah. So I mean.
My mind is blown.
Yeah. So and then like so shallow copies. So slices make shallow copies, which basically means your copy goes one level deep. The converse of that is a deep copy. If you just Google JavaScript deep copy, usually you'll see a few good kind of homegrown functions for writing it. But once again, usually those are more on an ad hoc basis. Like in the situation in which you would need to make deep copies, usually you have a very specific use case in mind, and so you want to adapt your function specifically to fit with what you want it to do. That's pretty much it. Yeah.
So the new functionality of the spread operator.
Yep.
Does it do the same thing that slice does or no? The three dots. I'm not sure if I'm putting the right name.
In what context?
So when you want to copy the element of one array to the other array.
All right. So let me know what type here. Let's test it out.
It's so you create an array.
Yep.
And then create a couple numbers and create another array with empty array. Yeah.
Mm-hmm.
And so you put three dots and ARR. I saw it. It was like
Like that?
Sort of like this. So what it does, it takes those elements.
Oh, sorry. Is this the right text?
Yes.
Great. I'm just gonna run the code then.
I'm not 100% sure, but I saw.
Okay. So it looks like that worked. And then the way for us to test this now, what you're saying is basically, is this equal to ARR2? This would give us false.
So it does a copy. Oh yeah.
Great. Yeah. So it looks like it's making a shallow copy.
The same. Okay.
Yeah. It looks like it's also.
It's just easy.
Yeah. Yes. It looks like the shallow copy, right? Because ARR2 look the exact same, but when I do a comparison of ARR's third element compared with ARR2's third element, I get back true, which means these two have the same reference.
Yeah.
Which must mean that they're both looking at the same array.
What is that dot dot dot?
It's a spread operator. It's something that came out in ES6. It basically lets you pass in an array of things kind of one at a time. It's a shorthand notation. There's probably not too much of a use for it to talk about too much in this class, mostly because I have limited time, and so like this probably is it's a nifty shortcut, but it probably does like more confusion than not. You'll definitely learn more about it in the full-time curriculum about a lot of these ES6 shortcuts, but just know that it is a shortcut. It doesn't let you do anything that you can't already do right now with what you know, right? It just makes it look a little bit cleaner, but more window dressing than anything else. Yeah. And honestly, like this is what I just did here. Like I didn't know the answer, but like with most of these things, you know, you're at a level now where you want to get to a point where you can just test things out yourself, right? Like, rather than like, oh, I wonder if this is true or not. Like you just, you know, really quickly prove out whether or not it's true. So another reason why like memorization is actually not as helpful in programming when you have like ability to test things. Cool. Any other questions? All right, great. How
Are you going to go through the previous exercises